Hello, today is the 15th November. We have a reason to talk about CQRS and event sourcing. Yeah, Reza, you can just go ahead.
Okay. Uh, so Emily, thank you for having me back. So just by way of review, on the first session that was about a week ago, we basically began our discussion about CQRS event sourcing and Axon. We did cover quite a bit of materials in the last session. I would say near about 60% of the material that I would have covered. So today we're going to cover the rest of it, try to cover the rest of it. I'm going to start by doing a brief review instead of just assuming no prior knowledge whatsoever. I won't spend too much time on it, but just want to briefly go over the slides once again, just to more than anything else jog everyone's memory. Okay, so here we go. And for some odd reason, I'm unable to use my keys. There we go. We finally are able to use my keys. So I started by explaining CQRS, which stands for Command Query Responsibility Segregation. Talked about the basic motivation for CQRS, which is basically to avoid extremely complex queries and slow queries in the system. That's the principal original driving force behind CQRS. We talked about what CQRS is and how it actually looks like, namely separating the read model from the write model, and then having some synchronization mechanism whereby changes to the write model wind up in the read model. We talked about the basic motivation there, and also some of the other important side effects, like being able to physically scale up and down the read sides and write sides separately, because they are two separate models in the application. Choosing perhaps the right data storage. In case of CQRS, it would definitely be, rather event sourcing, that would definitely be the case. Usually event from the way you would expect your traditional relational model to look like. And of course, CQRS is almost a must to enable event sourcing, and that's often why CQRS and event sourcing are talked about together. I talked about a little bit of event sourcing. Essentially, it's a different way of storing and looking at data, as opposed to simply storing current state. What you store in an event store is, given an aggregate, everything that happened to it in terms of events in the system that's meaningful to a business domain. And then what you do is, when you actually need current state, you essentially replay and aggregate all of the events that happen to that bit of data to understand what the current state is. CQRS and event sourcing, as I said, are intrinsically tied together. So often an event stored data will essentially emit events, and those events are the synchronization mechanism whereby the read model is updated. It provides a natural audit trail. That's often the key motivation for using event sourcing, principally for organizations that have regulatory requirements or very mission critical general ledger issues where they need to know, okay, what is only the current state of the data, but why at any given point in time did you arrive there? Event sourcing helps with producing ad hoc temporal reports, because you have essentially a complete record of everything that happened in the system at any point in time. Similarly, it's useful for analytics, where you cannot predict beforehand what it is that you are looking for. And also, CQRS entails very efficient writes, the most efficient writes possible, because all you're really doing is appending to an event log in the end. It does provide greater design flexibility as compared with CRUD applications, because you can essentially very easily change the read side of your model to adapt to business changes. Why Axon? Obviously, you can do all this stuff by hand, but it would be sort of foolish to do so, because there's a lot of nuances with CQRS and ES. It's better to go with a shared solution, like a framework that solves a lot of these problems for you, as opposed to maintaining this code by hand. And similarly, in general, when you're going that route, you'll wind up with better production-ready quality, because this is a shared solution as opposed to a solution you're developing in-house and only you use. Axon also provides a nice API guidance in terms of implementing CQRS and event sourcing. And it also provides a nice side effect whereby the code is separated from the configuration, and you can essentially make different configuration decisions as you go along, as you evolve your application without needing to evolve the actual application code very much. The most important aspect of this is location transparency. So in a microservices-based system, you could easily split out your application into separate components as your needs evolve, and you wouldn't need to change your Axon code. All you really need to be changing is the Axon configuration. So we used the card application to do all of this and sort of show us how the code looks like. The application is available on GitHub. And essentially everything that I'm showing you today, you can step-by-step set up yourself and explore the code a little bit more. And I also showed you how the application looks like last time, as well as how the event store and outline database looks like behind it. So we began. Actually, let me stop there for a second and provide an opportunity to ask any questions and review so far.
Has the audio gone bad for anyone else?
Yeah, Marcia, you need to go on mute. You have a lot of background noise, and that's making Rez's mind quiet.
Yeah, let me mute the oh.
Hi, can you hear me though?
Yeah, I can hear you now. Before I say you, yeah, I can hear you now. Thank you.
Oh,
Go ahead.
Was the audio so bad that I should repeat just start from very beginning?
Repeat
No, just like the last 2 minutes.
Last 2 minutes. Yeah, exactly.
Last how many minutes? I'm sorry. Emily?
Like the last 1 or 2 minutes.
Yeah.
Last 2 minutes.
Yeah.
All right, let's do that. All right. We also covered why you should use Axon to do any of these things. So most of you are probably familiar with the reasons why you would want to not hand code something like CQRS and event sourcing. It looks simple on the surface, but there's a lot of complex things that you need to consider in terms of low-level implementation details that something like Axon would provide, as opposed to writing this stuff yourself. Obviously, that also means that you're not using the solution only yourself within your own walls. It'll be a solution that is used by many different people and transitively would probably be much more production ready and would have less bugs than something you would develop in-house. Axon also provides APIs as guidance, so you don't have to reinvent the wheel in how these design patterns actually look like in Java code. If you just use Axon, you more or less will be constrained to a certain design paradigm which fits CQRS and event sourcing. And also, one of the nice things about using Axon is it separates configuration from the actual business logic. What that means is that you can change the configuration without needing to rewrite or change the business logic much. This especially comes in handy with the concept of location transparency and microservices. So for example, if you wanted to relocate one of your application components, you could very easily do that by simply changing Axon configuration as opposed to needing to make wholesale changes to your business application. So we looked at all of this through a simple example called gift card. Gift card is on GitHub, as you can see there. So this is the repository for it. The objective of the gift card repository is obviously to give you first-hand access to CQRS, ES, and Axon code, but also the demo that I ran yesterday, you could run yourself because there are instructions on how to do so. I did show you the application briefly last time, and I also showed you how the database looks like, how the data is actually stored, both the event sourcing data as well as the read side of the data. So I think before I go any further, I would just like to pause just a little bit to give us an opportunity to have Any questions on the review so far?
Yeah, sounds good. I don't have any questions.
Okay, right. So let's move forward. We began exploring the code last time. So we started and can everyone see the code, by the way, or should I increase the font size?
It looks good.
Okay, all right. Let's move forward then. So one of the key artifacts in Axon is what's called the aggregate. So this is the data that is actually event sourced and stored in the event store. So in order to identify an aggregate, you simply need an annotation called @aggregate. This is an Axon specific annotation. Every aggregate also needs an ID. So over here you would you could use the @ID annotation from JPA. There is also an Axon specific annotation if you choose to use that. It's called @identifier. But the main point here is every aggregate needs an ID. An aggregate can also have sort of rather materialized data, right? Materialized state, the materialized current state. You often need this because in order to execute changes or to process commands in an aggregate, you often will need access to this data. You need to know what the current state is in order to be able to change that state. So certainly Axon provides you that capability. In this case, it's we have our aggregate is gift card, and the materialized state that we're maintaining only in memory is a remaining value. So as you can see here, this is an interesting paradigm. So this is a command handler, and this is handling a command for issuing a new card, and it happens to be the constructor. So what happens here is that as a result of handling this issue command, we actually create a new aggregate instance. So as you can see, we need to validate that we can actually execute this operation, and then if you can, then we simply issue the event with this apply method, and what that ultimately does is store the data in the event store and also transmit it across the system to anyone that needs to listen to it. Similar thing for redeeming card value, and as you can see here, we're using the remaining value aggregate state. And beyond that, we also need to actually mutate the state of the aggregate. You don't do that before issuing the event, because the events are ultimately replayed. Whenever an existing entity is brought into service in Axon, what Axon does is it replays all of the events from the beginning of time to essentially bring that entity up to speed into what its current materialized state is. So what you actually do is you apply the changes in an event sourcing handler. So this is a very specialized type of event handler that is essentially changing the internal state of the aggregate that actually produced the event, right? So over here is where we would set the ID, so the remaining value, as you can see, and so on. So this is where we stopped last time. So I just want to answer any questions here, any remaining questions here before we move on.
I have a quick question, just to be able to understand this. So aggregate is basically the equivalent, like to say entity, right? So basically you operate on an object, and then these objects can have different commands. So aggregate, basically you define this kind of central object. Am I right?
Yes, you're exactly right. So an aggregate is, in terms of domain-driven design, so first of all, you're correct. If you were to make an analogy with JPA, an aggregate is basically a highly specialized type of entity. In terms of domain-driven design, in fact, an aggregate is an entity. So an aggregate is a specialized type of entity. It's an entity that controls access and controls consistency boundaries of an underlying set of entities. In fact, you could have I could have an entity set of entities here that are that have a contains relationship with the aggregate. Right? So I could have a field here that says, for example, private transactions. Well, sorry. stupid of me, sit list. And this is a model that Axon will support. So these transactions could actually be entity objects, and Axon will manage the state of both the aggregate as well as the nested entities within them. So yes, you're correct. An aggregate is basically equivalent to an entity in JPA. And yes, the set of aggregates would model your application, just as you would model your application using entities in JPA. In this case, you would model the right side of your application using aggregates.
Okay, thank you. Thank you. So for the command handler and event sourcing handler, for the command handler, it looks like this kind of issue of event, right?
That's correct. Its main purpose in life is to see if a change can be executed in the system, so to validate whether a change can be executed in the system. The change is executed by applying an event, yes. Applying one or more events, yes.
So when the event sourcing handler will be called then?
The event sourcing handler will be invoked right before, right after an event is actually stored in the underlying event store, and before any other event handlers are invoked. So it is actually part of the atomic transaction of, it actually is part of the same transaction of command handling. It's part of the command handling chain.
So asking you for this example you highlighted here, this like a handle, the redeem command, and then this is on redeem event. So is that right? So like Axon automatically call the handle to fire this event, and then when that event is fired, automatically call the on redeem event.
That's right. So the sequence of events here, Emily, would be that we would issue the redeem command from somewhere, let's say the UI, and it would land in the command handler method, or the handle method here that you see on screen. It would execute whatever it is that it needs to execute, and in the end, if the conditions are correct, it will issue the apply method, which will result in Axon storing the redeem event in the event store, and then immediately transmitting that event to this event sourcing handler, so that the entity gets, the aggregate gets a chance to update its state corresponding to the change in the event store.
Okay, thank you.
Reza, I had a slight disconnection while you were talking, but can you just, the term aggregate, that's a DDD one, and is it consistent with the use of DDD? I heard you start the answer, but then it disconnected. So that's where the term comes from, right? In your usage, it's to do with DDD, yeah?
Yes, that's absolutely correct. So most of our terminology and most of our APIs, in fact, most of our documentation is aligned to DDD exactly. So we don't say explicitly that you have to use DDD in order to use Axon, but in all reality, as you know, both event sourcing and CQRS come from the DDD community, and most of our conceptually, API-wise and documentation-wise, everything is aligned to DDD. Yes. So this is the aggregate concept of aggregate in Axon is directly a direct implementation of the aggregate pattern in DDD.
Mm. And does it enforce things like root entities, root aggregate, that kind of thing, or is it just
No, it doesn't.
And you mentioned something about a transaction. I was hastily, that's the point I kind of reconnected back. So Was that to do with you've got an atomic transaction around a command handler or
That's
something?
correct. Yep.
So I guess it like dequeues the redeem command, does the processing, sends the redeemed event, and then commits once the handle method returns, and that's how you deal with redelivery of a command not getting reprocessed or something, like inconsistencies there.
Yes.
Is that right? Yeah, okay.
That's
Just
right.
wanted to check. Thank
Yep,
you.
and we call it unit of work. And you can actually get a handle to the unit of work in the event source. You could inject something like this. Okay, you can get a handle to it, and you can, if you needed to, you could manually essentially revert the transaction in the event sourcing handler only, not the regular event handlers. The regular event handlers happen after the fact, after the transaction is committed, but not the event sourcing handlers. The event sourcing handlers are invoked in the same transaction as the commit.
I was under the impression the event sourcing handler was called in like an application recovery situation, repeatedly getting the same events again to like build up the current state. I thought that was the thing that replayed to accumulate the state in the aggregate, like the remaining value basically starts at 0, and then it gets all these redeemed events sent to it to bring it back up to the materialized state or something, I think you called it.
Yes, that's exactly right too. In that case, your unit of work would actually be the entire replay.
Okay, and what would you do with the unit of work, sorry?
You can revert the current transaction. You can say something has gone wrong. I can't this replay or the actual command that caused this event handler to happen, that needs to be reverted because something has gone wrong.
And that's when it's replaying all these events in this sort of restarting scenario. Then
Remember, there's two different ways this could be invoked, right? Generally speaking, one is that these events are already this aggregate already exists, and it is being rehydrated from the event store because the application is starting up, and it needs an instance to this particular gift card. And this event sourcing handler would be invoked in that case against every single stored event, right? So that's one scenario.
And that scenario, do you use the unit of work or not? And would that have an effect? I guess.
Yes, you can use the unit of work to essentially revert the entire replay, and you can even get a handle to the replay itself as well. You can inject also the replay to see whether on the event sourcing handler to understand whether you're being invoked as part of a replay or the other scenario, which is you're being invoked due to the invocation of a command handler.
Okay.
But these are obviously more nuanced, more lower level that we may or may not need to know right now. But yeah, conceptually, basically, you have the command handler. It issues an event, and then the event sourcing handler is invoked to reconcile the materialized state of the aggregate with the fact that you now have a new event that was applied. And also, in order to rehydrate the entity as well, aggregate as well, you would get an invocation of the event sourcing handlers in that case as well, which is why you need to separate out, which is why the state mutation always needs to happen in the event sourcing handler, not the command handler. And these are very common things. This is a thing that people sort of get have a hard time understanding with Axon because it's different from how you would handle, for example, how you would write, for example, a JPA entity, right? You would probably the most natural thing to do is just change the state in the command handler, but that won't work in this case because it breaks the ability to replay and reconstitute the state of the aggregate. Okay. Any other questions? I know this is a part where it gets a little bit more complicated to understand CQRS and event sourcing in Axon. It's just a different way of thinking about modeling your objects than your usual CRUD application.
So it's when the command handler, when the redeem command was issued, when that issued, so the handle redeem command will be called. Where is that code?
So
Where is that issued? Mm-hmm.
In our application, it's in the UI. So I'll pull up the UI here, so you can take a look. The UI code doesn't. I don't really want to dig into it too much because most of it is nothing to do with Axon. It's really more to do with Vaadin. But I'll show you the key aspects of it. So over here, as you can see, what we're doing is this is a managed object. When it is managed, we're getting a handle to a command gateway. And the command gateway, if you look at the import statements, is actually a Axon artifact. Right? So Axon manages this. If you will, this is equivalent to a JMS template, or rather JMS context. Right? So this is your handle by which you actually send messages into Axon, if you will, or send more specifically. In Axon we call it messages too. Never mind. So in this case, where the specific type of message you'll send is a command, right? But the main point here is that you are injecting the command gateway, which is an object that is managed by Axon. And then when you are ready, for example, when you actually click a button, like the bulk issue panel or the redeem panel or what have you. Well, let's look at the bulk issue panel. So over here, what happens is you have a registered event handler to handle the click, right? And what you would do here is do whatever parsing you need to do, but ultimately you invoke command gateway.send and await. There's many different ways, and there's many different variants of this, right? But this is the simplest one. So what we're doing is we're creating the issue command, and saying we need to issue a new card, and we are doing a synchronous invocation in this case of send and await. It actually waits for the command handler method to finish. By the way, you can actually return something in the command handler method too, if you so wish. It's discouraged to do so, but you can if you so wish. For example, you needed to return a status to tell you whether a command successfully executed or what the end result was, typically to return an ID. But anyway, so send and await is one option. You can also do an asynchronous send if you wish. You could use callbacks. You could return a completable future. So there's many different robust options available of how you actually send a command. But to answer your question, Emily, this is where the command would be issued. It's issued from the UI code.
Yeah, great. No, I know the full picture now. Thank you.
Okay. Anything else? Okay, I'm going to assume no, so I'm going to just move forward. I'll show you the commands real quick. There's nothing really too exciting. They're mostly just POJOs. The only nuance is actually you don't need a target aggregate identifier for this, but it doesn't hurt to have it. Assume this doesn't exist for a moment, but this is just a POJO with just a set of getters and setters. And the event similarly there's nothing anything really special to it. It's just a POJO. Again, in this case, it's a little bit complicated because in the end, the event is serialized into the database. So I have a few JSON annotations that tells the underlying serialization mechanism how to actually store and rehydrate this entity from the event store. But this is how a command in general looks like. It's a POJO. You have to give it a target aggregate identifier, which tells Axon that land this command to an entity instance that matches this ID. right? So there's a one-to-one correlation between this ID and essentially this ID. Okay, so that's the only thing you need to know in terms of commands, but other than that, they could basically be any POJOs that you so wish. So that's it for the...
Reza,
Yes.
I don't understand why you need to target a command at a specific instance.
Ultimately, all commands will be issued to a given entity, right? A given entity instance. So in other words, if you want to redeem, in our example, if you want to redeem the value of a gift card, well, you're redeeming the value of a specific gift card, right? So ultimately a specific gift card instance. So the way you identify which gift card you want is by specifying an ID. By saying, so what this is really saying is redeem this amount, the specified amount, for a for the ID for a gift card with this ID.
Got you. Thanks.
Okay. So that's it for the command side, if you will. So let me just move on from there. Let's now talk about the query side a little bit. So the query side consists of really two different things. One is whatever it is that that your mechanism is for materializing your view state, right, or materialized views. In this case, I'm simply using JPA to constitute my materialized state. So let's start there a little bit, and then talk about how Axon plays in. Hopefully, this part is very familiar to you. So this is card summary. So this is the entity representing sort of our view model to tell us, okay, what is the current state of all the cards. It's a JPA entity. There's nothing Axon about this at all. There's a few named queries, as you can see. It's just a JPA entity. Nothing much going on here. The JPA, the Axon port comes in the projection, right? So let's take a look at the projection next. So this is the projection. And the purpose of the projection is simply to read events that are being emitted by the event store and then act upon them. So in this case, essentially creating and updating the view model. So let's see how that looks like for a moment. So this is, for example, the event handler for the issued event. Okay, so at this point in time, this change has already taken place on the right side. We're now updating the read side to sync to it. So what we do here is we read the issued event. As you can see, we can read various bits of metadata, but the one bit of metadata that I want to read in this case is the timestamp when the event was triggered, and you can do that in semantics that you see at the moment there. So what all we're really doing here, ignore this for a second. This is, I think, maybe out of scope for today's discussion. This has to do with essentially this is showing how you can manually issue an event. You can do that if you so wish. I'm using that to update my UI state, but just forget about that line for a second. So all I'm really doing here is that when a card is issued, I create a new card summary entity, give it the information that I need, and simply call entity_manager.persist. Right? So I'm persisting the state. The reason I'm doing that is down below, is when I need to process a query. Okay, I'm essentially looking into those card summary objects and producing my query to produce my view. But let's talk about that in a second. So that's the purpose of the event handler, basically. And the event handler could be anywhere. It could be in the same JVM as the right side. It could be on a different JVM altogether. It doesn't really matter. Similar thing for the redeem event here. So we simply are looking up the entity, making any updates that we may need to make, and that's it. That's really all that this is here. And this doesn't be JPA. It could be anything any particular view technology. The main point here is that basically we have an event handler, and then we are given the event with any any metadata that we may need, and then we simply do whatever it is that we need to do to handle this event. So let's talk a little bit about another artifact that
Reza?
Yes.
I'm guessing there's like a XA transaction between line 42 and 45 to make sure if you replay the event. Well, how do you stop the replaying of the redeemed event doing multiple updates to the entity manager?
I don't follow. What was the question? Hi, can you hear me?
Sorry, I think I was toggling the mute the wrong way. This projection receives a redeemed event on line 42, and then on line 46, it sets the remaining value of the entity from the database to some new value. And then what happens if this projection, so when that set remaining value is done, is that done within the scope of a transaction?
It can be. It's up to you. You can do it in whatever way that you wish. So Axon, at this point in time, all that Axon does is that it knows that there is an event handler that needs to be invoked, and it makes sure that on the emitting side, it makes sure that events are emitted in the order that they occur. But then it's really up to the read side what it wants to do in terms of handling concurrency. So in this case,
I wasn't thinking about concurrency. I was thinking about if the redeemed, if this is the place where the database is updated, isn't it? This is the main place in a projection, is where you would update the database. You do a write into the database during a projection. Have I understood that correctly?
yes.
So if you write into the database the remaining value, and then this projection, the JVM hosting this projection crashes, and then the projection restarts, will it receive the redeemed event again if it hasn't somehow acknowledged it? So I'm saying it does line 46, which puts it in the database and crashes immediately after that. When it restarts, does it get the redeemed event again? And if not, how did Axon decide whether or not to resend it?
I see. Yes, so this is going, let me explain at a high level. I'll explain the lower level a little bit, but in not too much detail probably. So this is atomic from an Axon standpoint, not necessarily from the database standpoint. That's up to the projection implementation. But from an Axon standpoint, this is an atomic operation. So the actual event is not acknowledged to be received unless this method successfully executes until the end. So what that means is if there was, for example, as you say, this crash in the middle or through an unexpected runtime exception, Axon would not actually acknowledge the receipt of this event. So it would actually roll it back and say, I didn't receive this event. So next time, what's called the underlying event bus, or rather message processing handler, we have something called a message processing handler that actually manages the delivery of all these messages. That would actually not acknowledge this unless the event handler successfully executed. So under the hood, it's not as simple as that. We have different types of message handlers. One, by default, what you get is an in-memory handler. And that actually just delivers the messages in the same thread in which the messages were generated. So in that case, you would actually not get recovery at all. So if the entire JVM crashed in that case, you would just lose that message. Most people don't do that anymore. Most people beyond just getting started with Axon don't use and in memory message processor, what they use is what's called a tracking processor. And what that does is that it actually keeps track of the current read position of the event for a given message listener. So presumably you would have a message listener on a separate JVM, for example, and then that would only acknowledge that this event was processed if this method succeeded successfully. If it didn't, then you would simply get that message back the next time the JVM came up.
So that was why I was asking if the atomicity of that event extended to the database update, because if it did re-receive the redeemed event, it would end up basically reducing the remaining value by twofold, for example, if it replayed it once.
True. So what you would need to do in that case is that you need to make sure that this method is atomic from the database's perspective as well. So the way you could do that, for example, is that this event handler could be a stateless session bean, right? And what would happen is the commit wouldn't actually happen unless you successfully exited this method, and that would correspond to essentially Axon's notion of atomicity, right? So that's
would the stateful session bean be participating in the same transaction as Axon, though?
It can be. Yes.
Okay.
So you can configure Axon with an underlying transaction manager. So it would participate in the exact transaction manager that was managing this method. If this method were to be managed by an underlying, for example, container transaction manager.
Thank you.
Okay. Yes.
I have a quick question here. So previously you talk about command, is a kind of event source handler and the other command handler. Is that command handler? I can't remember now. And now this is a view. So in a view, you just have an event handler and a query handler. Is that right? So you have two handler, event handler and a query handler.
Let's forget about the query handler for now.
Okay. Let's just talk about event handler. For this event handler, when was this event was this event created? Basically, is the same event. Basically, on the UI, when you click on issue button, and this event will be created, and then this handler will be called, right?
That's right. Yeah.
Right. So I mean, in the previously, when you do a redeem card and an issue card, I mean, which one will be called first?
It depends on the order in which the commands were executed, Emily. But obviously, in most cases, you would assume that you would get the issued event first, and then subsequently you would get the redeem event.
So basically, okay, you will get the issue event code first. I'm trying to just put it in context with the previous file. Can you go back to the previous file, like on the other handlers?
Okay, let me try to see if I can do a split screen. I forgot how to do that exactly in NetBeans. If anybody knows offhand. Okay, so anyways, so this is the gift card. I'm not quite sure what to. Let's do this.
This is good. This is good. It is a gift card.
Give me just a moment, Emily. I can perhaps do a little bit better. So let's go here. So okay, and sorry. All right, let me put this on the, where are we here? Too many windows. Okay. All right, I don't know if this helps matters any at all. Okay, but here we have it. Okay, so here's the code side by side. Let me, for example, go to the issued event here. So this is the issued event.
Yeah, you issue that issue event. Yeah, and then here, yeah, you have a issue command.
Yes, that's correct.
So the issue command is basically command was when you click on the issue button. Let's just talk about issue, the action. So as a user, I went to the UI and then click a issue button. So that will generate a issue command, right? That will generate a issue command, and then will trigger this command handler gift card issue command. And then the issue command will fire issue event. So that issue event, if you on the right hand side, if you scroll a little bit further down, on the right hand side, no, this window, yeah. If you go, yeah. So that one is also like trigger the issue when the issue command was called, and then this kind of on issue event will be triggered, right?
That's
Yeah.
right. So these are
So
both. Yeah, go ahead.
so this is triggered, and also in this class also is a kind of event handler on issue event. So which one will be fired? Which one will be received first?
So this
I
one
assume,
always
yeah.
be received first. Yes, this is received first and always within the same transaction as.
Okay, this event source handler, this one will be received first and then followed by the other one. Can you go to the other one? Followed by this proper event handler, right?
That's right. Yes.
Okay.
I still don't understand. What is the difference between an event sourcing handler and an event handler?
Really, what it is that that is part of the. So the event sourcing handler is part of the same consistency boundary in terms of domain-driven design. So this is within the consistency boundary of this aggregate, right? So when the command handler actually executes its change, that change and this event sourcing handler is part of the same consistency boundary, right? So you're guaranteed that this change is going to happen when the actual event is when the actual command is processed. This event handler, on the other hand, is not part of the consistency boundary. Right? This is outside of the consistency boundary of the aggregate, which means this possibly may be processed asynchronously rather than synchronously. In most cases, in fact, they will be processed asynchronously rather than synchronously. So it's not part of the same transaction anymore. It's just a side effect of the event state changing, rather the right side changing.
That's clear now, thanks. Yeah. What's weird, I suppose, or not like obvious, is why you would ever want to, if you flick back to the gift card and go to the bottom of the file and try to get the method above on and the method at the bottom. So yeah, so that command handler a little bit higher, just slightly, maybe a couple of lines. Right, that command handler is processing the redeem command and it's generating a redeemed event. And I guess it's because you can replay the event sourcing handler. I just couldn't understand why you define an event sourcing handler in here if it was part of the same consistency boundary, but it's because that on method can be used for rehydration and processing the original command. Is that the motivation to have an event sourcing handler separate to a command handler in here?
Yes, that's exactly correct. Yes.
Okay, perfect. Thank you.
The other thing that I'm trying to, put it in the non-expert view is event sourcing handler is more like a precondition check, so that can and then if that check failed, so that that would be in the same atomic transaction with the event command. What is called event command handler, event command handler. And then if that failed, and then the event will not be fired, and then this event handler will not be driven. Am I right? Just
the command handler does the validation, I think.
That's right. Yeah, you generally have it right, Emily, except for, yes, you can think of this as preconditions to the actual event storage, successful event storage. You can think of this as post conditions.
Oh, that's a post conditions. Okay.
And
yeah.
not really be doing any validation here. You will simply be mutating the state of the aggregate. And
right. This is more like a login and etc. Right? Event sourcing handler or the
not logging per se. It's really changing the state. Actually changing the materialized state. If you have any materialized state, in this case we do, and in most cases you will have materialized state. And what this is doing is
remaining. Oh, I see. Okay, you change the state. Okay, I see. I understand now. Yeah, thank you.
Okay. All right. Is there anything else that I needed to cover here? No, not really. Okay, so that's about the event handler, and then finally we have an optional artifact called the query handler. Okay, so there's nothing saying in Axon you need to use a query handler. You don't really need to. So once you have the JPA data stored, you could use any mechanism to query that data, right? You could use just spin up an entity manager, create a named query against it, execute a result, and that's that, right? Axon doesn't particularly care if that's what you want to do, right? It's perfectly fine. However, similar to an event handler and a command handler, we do have another mechanism called a query handler, and you can choose to wish if you want. If you wish to use it, you can. So what this does is that the only distinction between using this mechanism and not using it is that it gives you an additional layer of abstraction, right? So when you have a query handler like this one, like the one that I have defined, you have a way to decouple the query handler from the query issuer. Exactly the same way that you can decouple the command handler from the command issuer, and even the event issuer and the event handler, right? For example, in this case, here's an example of issuing an event. You can issue events too if you so wish. It's not just a matter of issuing commands and queries. You can also issue events, but these are not event-sourced events. This is just transmitting this event. It's not actually storing it. Anyway, so you can use this additional abstraction. You don't have to. It's a 50-50 mix. Half of people do and half of them don't. This is not required per se by the CQRS and event sourcing design patterns. This is just something that we've found useful at Axon, because now what you can do is you can have the query issuer and query handler either on the same JVM or on different JVMs, and because all this communication is happening through an Axon query bus, you could decouple it and have these things be remote if you needed to. But honestly, that's a kind of a side discussion. The code was right there, so I just wanted to explain it more than anything else. I think that's about it in terms of what I would talk about for the query side. The query side is relatively simple by comparison, I think. This is just a UI code, not much point going through this either. Basically, all that happening here is show you this code once again. If I can load it, there we go. In the end, all that this is about is that it has a command gateway, a query, and a query gateway, and an update and an event bus. But all you really do here is that when you are ready, you can issue commands, and you can also issue queries if you so wish. So let me show you a example of issuing a query. So this is all issuing commands. Yeah. It's not here, it's in the data provider. Okay. So here we have it, right? So here's an example of issuing a query, right? Through the query gateway. But basically, you construct your query object just like you would a command, and then you send it. You get your results back, and you do whatever it is that you need to do with the results. The only other part really of note is the actual Axon configuration. Okay, so this is how that looks like. In case of CDI, this is a set of producers. So by and large, I'm just using the defaults that just comes with Axon. The moment you add Axon via Maven in your project, it just auto configures everything. All I'm doing really here is that I'm overriding the default configuration. So there's a few things I want to do here. So I want to use, instead of the default event store, event bus, I want to use an embedded events and an embedded event store, and it's just a simple event bus. It's just in memory, and that's only used in this case. For example, in the projection, this is the only case where it's used. I don't need to really persist these events. I can just keep them in memory, and I don't really care if I have an in-flight failure. And I'm also, by default, what we use is XML for serialization. I'm overriding that and saying, hey, I really want JSON as my serialization mechanism. But that's it. But you can basically configure this to be however you like. You can change any possible Axon configuration. You could say, instead of a database, I want to store to a MongoDB as a relational data store. I want to use Axon server as my underlying event store. I need 4 different command gateways for whatever the reason. I want to configure my event listeners, or we haven't talked about sagas yet, but saga listeners, saga managers. All of those things can be configured with things like, okay, I want to use a tracking processor, or I want to process only so many threads per time. I want the event ordering across nodes to be distributed in such a way, and so on. There's really almost literally a million different configuration overrides that you can do with Axon. But you do all of them in this outside of the application code, in the Axon configuration. Either in case of Spring, you would provide configuration objects. In case of CDI, you would essentially provide CDI producers. I'll show you an example of that. So here we go, GitHub. Example, Java EE source main. Okay. So here's the equivalent CDI example. Right? So it's an application scope bean that has a number of producers. So for example, I'm overriding the entity manager, overriding the entity manager provider, overriding the transaction manager. This is, by the way, we talked about synchronizing with the underlying container transaction manager. This is how you do it. Right? If there's, in case of Spring, if there is a transaction manager, Axon simply registers it. In this case, I'm manually needing to register the transaction manager. I'm specifying an event storage engine, token store, so on and so forth. But as I said, there's literally a million different things you could configure in Axon. Or in case of CDI, for example, you could override all of these different artifacts. But the main point there is that it provides location transparency. you don't have to change your code. You can change basically the configuration of your application to, for example, distribute what could start as a monolithic application. You could distribute out as a microservices application without an actual change to the application, because everything is decoupled anyway from the start. So it's rather easy to move actual components around. So we are at the hour now.
Yeah. Yeah. So this is great. I think this is natural break. And I assume for the event batching, you plug in the in-memory one. You can also plug in Kafka, right?
You can also plug in Kafka if you so wish. You can plug in QP. You can plug in Axon Server. So there's various options of what you could use for your query buses and command buses.
Okay, that's great.
Or event buses.
Right. So for, I know you are busy in the rest of this November. How about we get together in December, first week of December? We talk about Saga, because we haven't and then naturally run into the transaction.
Sure. Yeah. So if you look at this deck, the rest of the agenda is really talking about why this stuff matters in the microservices world. It ends with.
Oh yeah, that's good. Okay, so, that's excellent.
Okay. Yeah. So we can definitely do that as soon as I return back from Java 2 days. We can.
So you are going to Java 2 days?
Yeah.
Okay, we'll meet up and have a further discussion.
Okay, sounds good.
I will see you there, and then we can resume this in the first week of December.
Yeah.
Thank you so much.
Okay. All right.
Okay, what are others think? So Tom, Michael, Martin, what do you think? And Andy, any particular?
Well, I'm looking forward to hearing more about the transactions when we get to that point.
Okay, that sounds good. Okay, I will stop recording. I will publish a recording to YouTube and announce the link. Okay, bye. Thank you so much, Reza. I will see you week after.
Okay, very good.
Okay.
I'll talk to you soon.
Yeah. Bye, everybody.
Bye-bye.